Hello student, in this video we will discuss about the matrices and how we will define the matrices. Before starting the matrices, we will consider a set of simultaneous equations. Here I have three equations. Equation number 1, 2, 3. First equation is 4x plus 3y plus 7z equals to 0. And second equation is 2x plus 5y plus 3z equals to 0. Third equation is 1x plus 2y plus 6z equals to 0. These three equations makes a set of simultaneous equations. Uh, Here we have the coefficient of x is 4 in the equation number 1, and coefficient of y is 3, and coefficient of z is 7. In the equation 2 we have the coefficient of x is 2, coefficient of y is 5, and coefficient of z is 3. In the equation number 3 we have the coefficient of x is 1, coefficient of y is 2, coefficient of z is 3. Now we will put these coefficient of x, y, z from the equation 1 to 3 in such a manner. 4, 3, 7 is belonging to equation 1, and we will put it into a one row, and 2x 2, 5, 3 from the equation 2 belonging to we will put in second row, and 1, 2, 6 belonging to third equation we will put in third row. And these coefficient of x, y, z within the square bracket we put here, and this square bracket is denoted by capital letter A, and the dimension of this square bracket is 3 by 3. 3 by 3 is the dimension of this square brackets. It means that there are 3 rows and 3 columns. 4, 2, 1 is the one column, 3, 5, 2 is the second column, and 7, 3, 6 is the third column. So now we have a simple definition of a matrix, a system of numbers which are arranged in row and column and bounded by a bracket is called a matrix. There are few examples of a matrix. A is a matrix, capital B is also a matrix, and capital C is also a matrix. D and E is also a matrix. Here the capital A is the matrix of 4 elements. In one row we have 2 elements arranged, and rest of 2 elements arranged in second row. Similarly, in matrix B, 3 elements arranged in the one row, and rest of 3 elements is arranged in the second row. This is the dimension 2 by 3 of a matrix B. Next is matrix C. 9 elements arranged in the matrix C, whose dimension is 3 by 3, 3 rows and 3 columns. Again, matrix D, another example. Here we have 6 elements, 2 elements arranged in first row, second row we have also 2 elements, in third row we have also 2 elements, and 3 by 2 the row into column, 3 into 2 this arrangement of 6 elements. In the matrix E, the arrangement of 12 elements in 3 rows and 4 columns. Now we will discuss about the types of the matrices. First is the row matrix. If matrix has only a one row, there is only a one row and any number of columns. I have arranged 3 elements in a one row where we have 3 columns but in a one row. So 1 by 3 is the dimension of row matrix. Second is 4 elements arranged in a row, and we have 4 columns, first column, second column, third column, and fourth column. 1 into 4 is the dimension of this row matrix. Next matrix is 1 into 5 is the dimension of next matrix. We arranged here 5 elements in a row. This is the row matrix. After this, the next type of the matrix is column matrix. A matrix having one column only and any number of rows is called the column matrix. Here is the example. In a one column, we have arranged 3 elements. First element in first row, second element in second row, third element in third row, but there is only a one column. Next matrix 1 and 2 is arranged here in a one column. Next matrix is 1 2 3 4 are the element of this matrix, and we arranged these 4 elements in only a one column. Similarly, I have 5 elements and these 5 elements arranged in a one column, and this is also known as the column matrix whose dimension is 5 into 1. Next type of matrix is null matrix, which is also known as a zero matrix. Any matrix in which all the elements are 0, it is called a zero matrix or a null matrix. It is a very simplest matrix in which all the elements are 0. This first example, in this example I have the dimension of this matrix is 2 by 2. So the 2 elements in first row and rest of 2 elements in second row, but all the elements are 0, and this matrix is known as the null matrix. Similarly, in second matrix 2 by 3 is the dimension, and we will arrange here 6 zeros in 2 rows and 3 columns. All elements are 0, so it is also known as the null matrix. Similarly, 3 by 4, here is 12 elements and all elements are 0. This is the arrangement of the 12 0. And after this, the next is the very important type of matrix is square matrix. The square matrix in which the number of rows are equal to the number of columns, so it is called a square matrix. So there is the example of square matrix. I have 4 elements which arranged in 2 rows and 2 columns. Total number of elements in this 2 by 2 matrix are 4. The number of rows are equal to the number of columns. This is the square matrix of order 2 by 2. And next is 1 3 2 4 5 6 7 8 9. This is another matrix of order 3 by 3 is a square matrix. One more matrix we have the order of 4 by 4, which is also a square matrix. Number of rows are equal to the number of columns. Next important matrix is diagonal matrix. A square matrix is called a diagonal matrix if all the non-diagonal elements are 0. Here I have a square matrix of 3 by 3 in which I have arranged 9 elements in 3 rows and 3 columns. So the diagonal elements are non-zero. This is my diagonal 1 2 3. This is my diagonal. The diagonal is non-zero and rest of elements are 0. So this is called a diagonal matrix of order 3 by 3. Now we will consider a diagonal matrix of order 2 by 2. This is my diagonal matrix of order 2 by 2 in which the diagonal is non-zero elements in diagonal and rest of elements are 0. This is the diagonal matrix of order 2 by 2. One more matrix of diagonal matrix of order 4 by 4. The diagonal is non-zero and rest of elements are 0. So diagonal elements is a very important. Next type of the matrix is scalar matrix. The scalar matrix, a diagonal matrix in which all the diagonal elements are equal to the scalar, says K, is called the scalar matrix. There are the few examples. This is the 2 by 2 matrix whose diagonal elements are 4, 4. All the elements are same. Next is the example of the scalar matrix whose diagonal elements are 2, 2, 2. This matrix of order 3 by 3. Next, scalar matrix of order 4 by 4 whose diagonal elements are 3, 3, 3. So these are the scalar matrices. These are the example of the scalar matrices. We can write a scalar matrix A equals to Aij of order n cross n is a scalar if Aij equals to 0 when I is not equals to j, if the position of row is not equal to the position of column. If the position of row and column is equals to, then Aij equals to k. It will be a k. Next type of matrix is unit or identity. A square matrix is called a unit matrix if all the diagonal elements are unity and non-diagonal elements are 0. The unity matrix or identity matrix, a square matrix, it is also a square matrix whose diagonal elements are unit and non-diagonal elements are 0. So this is the unit matrix or identity matrix.